Right, this will be lesson 4.2 and 4.3. So 4.2 and 4.3 are a whole bunch of different ways to prove triangles congruent that do not require you to know all the different parts. Okay, so these are all going to be shortcut ways to prove triangles congruent. So if they're quadrilaterals or pentagons, some other kind of shapes, you're going to have to know all the pieces, all the angles that match up congruent, all the sides match up congruent. But for triangles, we'll have some shortcuts. Okay, so the definition was that if you know all the corresponding sides and angles are congruent, that makes the triangles congruent. Reminder also, third angles theorem. What are you given for third angles theorem? Two triangles and what? Two pairs of angles that are congruent. So if you have those congruent and you have these congruent, then the triangles will have their third angles congruent. So I'm going to call this like A and B. If you have two triangles and two pairs of congruent angles, then the third angles are congruent. So like angle A is congruent to angle B. Remember, that makes sense because they have to add to 180. So if both of them add to 180 and you take away the same amount for both of them, the leftovers have to be the same. Jerron, you need to be taking notes. Close it, like not just minimize it, close it. Close it. The game that you were just playing. No, double click and close it. Let me see all your open apps. Okay, it's right there. Close the app. Thank you. Is the third angles theorem a way to prove triangles congruent? So would we know that these triangles are congruent to each other? Yeah. If you don't know any side lengths, then you will not be able to say whether the triangles are congruent. So again, be careful with that because maybe they're congruent, but if you don't know any sides, angles alone is not enough. Okay, so you're going to see a bunch of shortcuts here. There will not be one that only uses angles. Okay, you have to have at least some sides in order to make triangles congruent. So by definition, you would have to know all the sides and all the angles match up. That's 6 pieces of information. All of these are going to be shortcut ways, so they're going to have less than 6 pieces of information, which is nice. You don't have to actually know all the information, all the different parts. Okay, so the first one, we're going to call this side, side, side congruence. I don't really care whether it's a postulate or theorem. You're just going to refer to this as side, side, side. If three sides of one triangle are congruent to 3 sides of another, then the triangles are congruent. So you're going to be given that pair of sides are the same, that pair of sides are the same, and this pair of sides are the same. Okay, so if you have 2 triangles and all the side lengths are known to be congruent pairwise, then the triangle is congruent by side, side, side congruence. So even though knowing just angles is not sufficient, knowing just sides is sufficient. That means if I handed you 3 sticks of a fixed length, and then I handed somebody else the same 3 sticks, there's only one way to put them together. Now maybe your triangle might be like rotated or flipped over, but the triangles will be the same size and shape. They'll be congruent. Okay, if I give you the angles, remember that you can blow it up or shrink it down proportionally and the triangles may be different sizes. But just sides is actually sufficient. All right, the second shortcut is side angle side congruence. And don't even worry about calling it a postulate or theorem. Side angle side congruence. So for side angle side, this is what it's going to look like. 2 pairs of sides. So it doesn't really matter which sides you know. I'm just going to grab 2 of the 3 sides. Okay, if 2 sides in the included angle. The included angle. Do you know what I mean by included angle? So if I have those 2 sides marked, what do you think the included angle is? Angle, not side. Which angle is the included angle? B. B, because it's between the two sides. So included means the one that's formed by the two sides that are known. Okay, if two sides, the included angle of one triangle are congruent to two sides in the included angle of a second triangle, then the triangles will be congruent. Okay, so if you have two pairs of sides and the angle that's formed by those sides congruent, then the triangles are congruent by side, angle, side congruence. Okay, the order of the letters matters because it tells you what you know. You have two sides and the angle between the two sides. Okay, two sides and then the angle that's between them. Okay, order matters. SAS means two sides and the included angle. All right, so the third one, angle, side, angle. Angle, side, angle congruence. Now, this time, instead of being given two sides and one angle, you're given what? Two angles and one side. So any two angles, doesn't matter which two I choose, just make sure you're picking corresponding ones. So let's say I use angle A congruent to angle D, and I know the angle C is congruent to angle F. Okay, this one says if two angles and the included side, two angles and the included side of one triangle are congruent to two angles in the included side of a second triangle, then the triangles are congruent. What do you think the included side would be for the first triangle? Segment AC, right? So it's the one that's between, included just means between the two angles that you know. Now again, angle, side, angle means angle, side, angle. It goes in that order. Okay, so if you have that situation, then the triangles are congruent by angle, side, angle congruence. Now again, the order of the letters tells you the order of congruence that you know. Okay, and then the last one that works for triangles in general is angle, angle, side. This one's a theorem, but again, I actually don't care if you know if it's a theorem or not. We'll just call it angle, angle, side congruence. Now, how is that going to be different than the previous one? Well, it's not included, right? Let's say I still have two pairs of angles as before, but Kara, name a pair of non-included sides. Say it again. In this triangle, is AB, BC, or AC not included? I'm not sure if I misheard you. Say it again. Okay, segment AB, right? So that is one option, right? There's a pair of non-included sides. So this one's called angle, angle, side because it's two angles and then a side. It's not the included side. It's one that follows the two angles that you know are congruent. Okay, so that would work. What's another option? So if I use the same pair of angles here, so let's say that you still knew those two were congruent. Oops. Those two were congruent to these two. Instead of using this non-included side, where is the other option for a non-included side? BC and EF. Okay, but it's got to go angle, angle, and then a side. The side is not included. So two angles in a non-included side of one triangle are congruent to the corresponding two angles and side of the second triangle, then the triangles are congruent. So again, there's two options here because there are two different pairs of sides that are non-included. So if you have two pairs of angles in a non-included side, then the triangles are congruent by angle, angle, side. Thank you. Okay, so again, the four options here are side, 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 angle, side, angle, side, angle, and angle, angle, side. Megan, I'm going to airdrop this to you. Make sure it's on. You think it's this one? Is that it? Or iPad 136? iPad 136 is you? Maggie, did that go through? No. Okay, are you sure it's on now? Okay. Okay, you're still not showing up. So I'll just send you an email. What's your middle initial? Okay, so I'm going to take those different ones and write them down here on the third page. We're going to do examples. Here are your shortcuts. Side, side, side. Okay, two sides in the included angle. So side, angle, side. Two angles and an included side. Or two angles and a non-included side. Okay, those are the four that we have for general triangles. Now, I want you to notice that angle side side is not a thing. Okay, we've got angle, we've got two sides and an included angle, but angle side side, not a thing. Can you remember that? Huh? I said, can you remember that? Also, side side angle, not a thing. Okay, that means that if I give you if I give you two sides and a non-included angle, there's not only one way to put them together to get a triangle. Okay, there is a website I can go to and show you that, but we'll deal with that later. Okay, should there be an angle, angle, angle congruence postulate? No. Because why? Yeah, if you don't know any side lengths, not possible for the triangles to be congruent. You have to have at least one pair of sides, right? And it has to be in the right spot, and one pair of sides between two angles that you know. I'm gonna just copy what I wrote up here. Okay, there's no angle, angle, angle because angles alone are not sufficient. You have to have at least one pair of sides between the two angles or a different combination. Just angles alone is not going to work. So the thing about side, side, angle, or angle, side, side is that if I give you two pairs of congruent sides, so if those are congruent, and then I have a pair of congruent sides here, and then I have an angle that's not the included angle. Okay, so this angle here is not the included. There's two ways you can finish off the triangle because of the only things that are fixed are those two sides and that angle. It's possible that when you put it together, the triangle looks like this, but it's also possible that when you put it together, the triangle looks like this. And that's because you don't have a fixed angle up here and you don't have a fixed side length down here. So if I hand two segments and an angle to Giron and ask him to put a triangle together, then I hand the same ones to Grant and ask him to put them together, they might not get the same triangle. Okay, so it's not possible to use side, side, angle, or angle, side, side, because it's just not true. It's not true that if you have two sides and a non-included angle, that you necessarily get the same triangle. Okay, so just watch out for that because angle, side, 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 angle doesn't work. The exception being, our last one here is going to be only for right triangles. Okay, this one is called HL congruence. H for hypotenuse, L for leg. Okay, HL congruence says that if you have two right triangles, this only works for right triangles because regular triangles that are not right triangles don't have a hypotenuse, right? They don't have a hypotenuse and leg. So this is only for right triangles. If the leg and hypotenuse of one right triangle is congruent to the leg and hypotenuse of another right triangle. So this is what it's going to look like. For hypotenuse leg, you'll have two right triangles. Draw yourself a right triangle there, mark the right angle. I'm going to go ahead and just copy this over. Okay, if you know, which side is the hypotenuse? Okay, where is it? Across from what? Yeah, it's across from the right angle, right? The hypotenuse is across from the right angle, the legs are the other two sides. So if we know the hypotenuses are the same, and we know a pair of legs are the same, then those triangles are congruent by HL. And again, it's only going to work for right triangles because they're the only triangles that have a hypotenuse and a leg. In general, so that you might look at this and think, oh, it's angle side side, that doesn't work. Well, in general, it doesn't, but for right triangles, it does, but you don't call it angle side side, you call it HL. Okay, if the legs and hypotenuse of two right triangles are congruent, then the triangles are congruent by HL. Okay, we're going to skip those proofs for a minute because I want to make sure we get enough time to talk about the some examples down here. So add hypotenuse leg to your list. And these are the ways that we have to prove triangles congruent. Okay, side, 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 angle, 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 side, and HL. All right, so we're going to go through and mark things that we can figure out in addition to what is given. So you're going to have some kind of information given on the diagram, and then we're going to go through and figure out some other things. So for the first one, what you're told is that segment RS and segment TS are congruent. So that's given. And then it tells you that V is the midpoint of segment RT. Max, what can you get from the fact that V is a midpoint? What can I mark? What does it tell you that V is a midpoint? What is that? What information is that providing? Okay, so what can I mark congruent? What segments are congruent? It says V is the midpoint of segment RT. Segment RT is right here. If V is the midpoint of that segment, what segments are congruent? The two segments are. There we go. Okay. TV and RV would be congruent. Now I'm going to put 2 marks on it because I already have the other 2 segments marked with 1 mark. So it's really important you don't just put 1 mark on everything. You got to make sure they're paired up. Okay. That is the reason for that is definition of what? Midpoint. We know that's true because that's what a midpoint does. So a midpoint divides into 2 congruent parts. Okay. Now, there's something we talked about just a few minutes ago that we could also mark here. What else could we mark? Jake? Okay, a midpoint does not have to make a right angle. Okay, so like it looks like it's drawn to be right, but I don't want you to assume that. Kara? Okay, if you know they are the included angle, but you can't use that as a reason. If we knew R and T were congruent, then we could say the triangles were congruent using side angle side. But you can't use that as a reason. Like maybe you'd want them to be congruent, but that doesn't make them congruent. Huh? If you knew R and T were congruent, then it would be a side angle side. We just don't know that. I'm going to mark this last pair. Anytime you have a shared segment like that, you want to use that as one of your pieces. What's the reason for why I can mark that congruent? Why is segment VS congruent to segment VS? That's reflexive. You're going to do this so much, you're going to be sick of always using reflexive. But reflexive is a super easy way to get parts that are congruent. So anytime that triangles have a shared part like that, it's usually segments, but if there are shared segments, then you can mark them congruent. Okay, do we have enough to use any of those different ways up there? Jake? Side, side, side. We have all the pairs of sides, so triangle is congruent by side, side, side. Okay, how about we jump to, let's look at this one. Top row, third one, far right. Okay, first thing you want to do is mark anything that's given that's not marked on the picture. So angle S is congruent to angle V. Mark that. Okay, and then secondly, T is the midpoint of segment SV. Braden, tell me what that's going to give you. T is the midpoint of segment SV. What can I mark? ST and VT are congruent. Now again, with congruent figures, the order matters. So if you say from S to T, you should say from V to T because we're starting with the angles that correspond. All right, what is something that we could mark? Jake needs to take a break. Somebody else? Any of you guys? What else can I mark? Jerome? Yeah, what's the reason for that? Vertical angles are congruent. You're going to see a lot of this also. Okay, anytime you have two triangles like that where they're sharing the vertex because they're formed by intersecting lines, you'll get congruent vertical angles. All right, now the question is, do we have enough yet to use any of those? So we have two angles and a pair of sides. So two angles and a pair of sides, it looks like it's going to be one of these, right? So you have to decide which one is it. Well, remember the difference is angle, side, angle means that you have the side included between the two angles, whereas angle, angle, side means two angles followed by a side. So two angles and the side that's not included. So is that side that we know included between two angles or not included? Included, right? It goes angle and then a side, then an angle. Angle, side, angle. So that's going to make the triangles congruent. I'm just going to copy this here. Okay. Triangles congruent by angle, angle, side, angle. And again, the side that we know needs to be included between the two angles in order to use angle, side, angle. Okay, two angles and a side between them. All right, let's look at, how about the second row, first one, first column there. Gerbil, is there anything I could mark that's not currently marked? So two things we've talked about. We talked about reflexive and we talked about vertical angles. Okay, so I'm going to go ahead and mark RT congruent to RT, and the reason there is going to be reflexive. Make sure you're not just assuming things, okay? Every time you mark something, you should be able to justify why it's congruent. So do we have enough yet to say the triangles are congruent? Well, we have two angles and a side, so let's look. Two angles and a side could again either be angle, side, angle, or angle, angle, side. So where is the side in relation to the two angles that we know? Is it the included angle or included side, or is it a non-included side? Non-included. Where is the included side for the top triangle? ST. So if it's included, that means it's the side that forms both of those angles, right? Here's an angle, and it's the side that's like in between the two angles. That's not an included side. It's angle, angle, and then a side. Two angles and a non-included side. So the triangles are congruent by angle, angle, and then a side. Now that would be good. That's sufficient, no problem there. Somebody might look at this and say, okay, I actually could mark these congruent right here. How do you know those angles are congruent? Third angles theorem, right? So it would be possible for you to use third angles theorem. And then that would give you a different answer that would also work. What would that make? In addition to angle side, you could have also used what? So basically, if you just look at, I'm going to get rid of this. Oops. I'm going to get rid of this over here. Okay, that's not angle side. That's what? That's angle side angle. So the kind of easiest, quickest way would just be to use the reflexive side and then be finished. But it would be okay for you to also use angle side angle. But you got to make sure that you have marked those parts and that your answer matches the parts that are marked on the picture. Okay, so if you happen to think, all right, third angles theorem and then done the reflexive, either one of those answers would work. Just make sure that your markings match your answer. Okay, how about second row, middle column? Somebody who hasn't talked to me today. And that could include Sean, Lily, Blair, or Kendall. Any thoughts about that picture? Ryan, Colleen, Drew, Maggie. I think you're the only ones in here who I haven't talked to. Any thoughts about that one? Yeah, sorry about that. I kind of, when I was copying and pasting, I cut that off. That's a C and that's a Z. Yeah, I bet. Yeah, we don't know that. It'd be nice if they were, but we actually don't know that. For this one, there's really nothing else that you can mark. So the question is, from the markings, are those triangles congruent? Don't assume anything. We have two sides and an angle. So our options, sorry, our options will be either side angle side, or if it's angle side side, they're not congruent, or maybe there's not enough information. But the only one that might possibly work where yes, they are congruent is side angle side. Is this one side angle side? What is that one? That is side angle or angle side side. That's bad. Would this one look like it could be side angle side? Yeah. Yes. However, we've got the angle in the wrong spot, right? So because this one has the angle that's not included and this one has an angle that is included, the angle's not going to work. It's not in the right position for this one. So we're not going to be able to say if they're congruent. Okay, the angle's in the wrong position. Not in same place. So just be careful when you're matching things up that the angles and the sides that you're looking at kind of are in the same place. Okay, how about one with parallel? So remember that parallel, we can think of those as being cut by a transversal. The first thing I would recommend is that when you see parallel, you stretch them out. So you can see those as parallel lines. And then there are three different lines you could use as transversals. So maybe it's helpful to look at this segment as that line as a transversal. Maybe it's helpful to look at this line as a transversal, or maybe it's helpful to look at this line as a transversal. Okay, so if we're using those parallel lines, which of those transversals will be helpful to give us angles that we could use in the two different triangles? Helpful to use this one, or this one. The diagonal one. Okay, Kara, what do you notice? Okay, it's not opposite. What's the right word? Alternate interior. So because the lines are parallel, we can use alternate interior angles are congruent. So the reason would be if lines are parallel, then alternate interior angles are congruent. Okay, so right now we have a pair of, now another thing, these parallel segments happen to be congruent, but you know in general, parallel segments don't have to be congruent. The reason that they give you parallel is so you can find angles. You can use those ideas from the last chapter. So helpful hint here. They give you parallel in order to get angles. A lot of times it might be alternate interior, but you know, it could be like corresponding or like whatever. The parallels are provided in order for you to figure out some angles. Now, Maggie, is there anything else that I could mark that's not currently marked? So we have a pair of sides that was given, we have a pair of angles that was given, that we just figured out. Okay, Max, what do you think? We don't know that. So yeah, and again, make sure you don't assume things, in particular right angles. Right angles are things that students a lot of times try to just make like, oh, I want them to be congruent, I'll make them right angles. Okay. Good. So again, anytime you have a shared segment, you want to use that. Okay, it's kind of like they've given you a freebie, you just have to recognize it. So that one's going to be reflexive property of congruence. Now, those are justifications for how we can mark things congruent. What you want to look at now is what you actually know to be congruent. So we know we have these sides and that side, and then you have the angles here. So we have two sides and a pair of angles. So two pairs of sides and a pair of angles. So that might be this one. Remember that if it's, I'm gonna write this over here. I didn't really write that before, but make sure you're not using angle side side. Make sure you're not using angle side side or side side angle. Okay, those are not ways to prove triangles congruent because they just don't guarantee that you'll have only one triangle. So two sides and an angle has to be the included angle. So the question is, do we have two sides and an included angle, or is this going to be one that doesn't work because it's angle side side? So where is the angle in relation to the sides that we know? Is it included or not included? It's included. So the triangles are congruent by side angle side. Okay, and again, side angle side means you're going in order. Side, then an angle, then a side. Two sides and an angle that's between them. Okay, how about the one right below that? Drew, tell me that something I could mark that's not currently marked. Okay, we do know that's a midpoint, but I mean, I want another pair of segments or angles that we know could be congruent. This is a right angle. The other side is also a right angle, right? How do you know that, Colleen? Say it again. How do you know it has to be 90? This is a line, right? That's how much. Okay, so if we have 90 there, we're going to have 90 there, right? What we're actually using is linear pairs or supplementary. Right, so your linear pair is those two angles make up this line, right? So this one and this one are your linear pair, and they happen to be both right angles. So those are congruent because linear pairs are supplementary. And then anytime that you have right angles marked, you can always consider those to be congruent. So the other reason is all right angles are congruent. So even though they won't be marked, you know, like with the little arc congruent, you're always going to be able to say the right angles are congruent. Okay, so from what we have marked right now, do we have enough to say the triangles are congruent? So we have two sides and an angle. Two sides and an angle. So one option is two sides and an angle is side angle side. If it happens to be angle side side slash side side angle, it's not going to work. So do we have two sides and a pair of included angles? Jerron, where are the angles that are included between those sides? Are those the included angles? No, those are non-included angles. So we don't have enough yet to say the triangles are congruent, but okay, so first of all, can we use HL? Good point. Does HL work on this one? They're right triangles. Do you have hypotenuse marked? Yep. Do you have a pair of corresponding legs marked? Yep. Okay. So one option would be from what we've got marked there, we can say HL. Now, you might have, there's actually some other ways to do that. Kara? Okay, so another option would be side, side, side. Good. Sometimes there's more than one way to do it. You just have to make sure that your markings match with what you're saying. Okay, that would be side, side, side. Are there any others that could have worked? So how about mixing angles and sides? Anything that we could mix angles and sides? Let's kind of check, just look at the different ones. We use side, side, side. Does side angle side work for that one? Yeah, you could also use side angle side, right? You would still use reflexive, but if you did side angle side there, that would also work. So that means when I'm grading this, I have to like watch out that maybe you actually said something that's right, you just did it differently than somebody else. So what's important again is that you have the markings to support what you're saying. So any of those would actually work. Okay, so again, if you're using side angle side, it would be side and then the right angles and then the shared side. Okay, how about how about this is the third row down on the right side, middle row right side. Grant, is there something I can mark that's not currently marked? Good. So things that should jump out at you should always be vertical angles are congruent and reflexive property congruence. Those are like gimmies without necessarily having them marked. You just have to recognize it, and then that's something you can use. Okay, right now we have one pair of angles and one pair of sides. Notice that these little symbols mean what? Parallel. They are not necessarily congruent. Okay, so be careful about that because parallel segments are not necessarily congruent. Now, maybe they are, because like on that one that we had up here to the left, we had the marked congruent and parallel. But if they give you parallel, the purpose is for what? What did I tell you the purpose of parallel lines being given is? To give you angles. So I'm going to do the same thing that we did before. I'm going to highlight those two lines so that we can see them as parallel lines in a transversal. So there's two different transversals you could use, right? You just have to decide, is it helpful to use this transversal, or is it helpful to use this transversal? Or maybe it's either one would work, it would just give you different answers. So let's say that you use that transversal. Does that make the triangles congruent? So what angles could you get from that transversal? Let me go ahead and label these just to make it easier for us to talk about. Let's say it's A, B, C, D, and E. Angle A and angle E. So if you use that transversal, it's going to be angle A is congruent to angle E. Now again, be careful that if there's already one pair of angles marked with a single mark, make sure you mark the second one with 2 marks. Okay, I don't want to indicate that they're all the same. They're pairwise congruent. Okay, if I mark those, is that enough to make the triangles congruent? Ryan, what would be the reason? We have 2 angles and a pair of sides, so it's going to be one of those 2. Angle, angle, side. Good. Angle, angle, side. Now, let's say you use the other transversal instead. So I'm going to switch colors here. Let's say that I had used this transversal instead. So what angles would that give you if you use the other transversal? Okay, that would make B congruent to D. Or if you use third angle theorem, you could also get it that way. You would still use the pink transversal. If we used this instead, so I'm going to use this pair of angles, that pair of sides, and then the vertical angles. Is that still angle, angle, side? No, that's what? Angle, side, angle. So either one of those would be okay. But they would be different reasons. So again, it's important, and you don't have to give both answers, okay? One answer is sufficient. You don't have to give me all the different possibilities. Once you find an answer, just stop, you're done. Okay, I'm just saying that I would accept either of those answers as correct. As long as your markings indicate what you're claiming, you know, why they're congruent, then you're fine. Okay, how about one more? Which one do you want to look at? I think a few of those are too easy. Let's look at the one right below the one we were just looking at. Maggie, is there anything that I could mark that's not currently marked? Okay, the shared segment right there is reflexive. Again, every time you see a shared segment, this could also work with angles, but it hardly ever is for angles. Okay, every time you see a shared segment like that, you're going to be able to mark it and say it's reflexive. Do we have enough to say triangles are congruent? Yeah, what's the reason? Side angle, side. Now, just a word of caution. Sometimes students try to say, okay, I have 2 pairs of sides in a triangle, so I can mark the third pair of sides congruent. There is no side, like third sides theorem or something. So just be careful that if you're trying to use like 2 things are marked, so the third one can be, that's for angles. Okay, side, angle, side. I was going to say, oh, I'm sorry. Okay, your homework is going to be, you don't have to finish these. Your homework is going to be from the worksheet here. I think is probably a little bit simpler than some of the ones that we just did. On the second page, okay, so these, you need to mark, this is important, please listen to these instructions. make sure that you mark on the picture just like we did. Okay, when you mark a pair of angles, you got to tell me why they're congruent. You mark a pair of sides, tell me why they're congruent. And then say side, 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 or side angle side, or whatever the reason is. Okay. On the second page, it says, state what additional information must be given in order to know that triangles are congruent. So let's say, for example, you're doing number 15. What else would you have to know in order to prove those triangles congruent by hypotenuse leg? You need the hypotenuses. So what you're going to say is segment JK is congruent to segment UV. Okay, don't just mark it on the picture. Actually write what it should be. See where it says state what additional information. State the additional information. Do not just mark it on the picture. Actually write segment JK needs to be congruent to segment UV. Now you can mark it on the picture if you want, but you need to state the information. Okay, and if you were to mark that, that would have 2 marks on it, right? Because you already have a pair that's congruent that way.